don't know why it was happened, right? Then put your registration number and also your name, right? Registration number dash your name. Then I can take the attendance. And also there is one question here, right? So can you share the notes, right? From somewhere, right? Okay, from how I can share the notes, right? Shall I upload it into somewhere, or shall I email it, or what is the way that I can share the notes? Notes mean this, I think, this slide set.
So you can share it with Google Classroom, or you can share it with chat in Zoom meeting.
Right, then I will put them in Google Classroom, right? Then it will be easy, neither. I will put them in the Google Classroom. Then you can download them, ne?
Yes, sir.
Right. Then we will do like that, right? Then we will do like that. Then, sorry for the delay. However, that is also not my problem. However, since 4:20, since 4:20, I'm trying to join, but I think some kind of issue from the Learn site, right? Learn Zoom account site, maybe some kind of authentication error, I think. I don't know what is that. However, finally I got logged in. However, then we will conduct the lecture, right? I think, is it this time period is okay? Now we started at nearly 4:50, right? Then I think, can you participate in the lecture series until 6:50, nearly 6:45 at least? It is possible, ne? Right? Like we will try to conclude around 6:45, right? Then another message for you, right? Then normally I show now today when I was logging to WhatsApp now, because today I am totally busy with some kind of meetings, right? Then meetings was actually over at nearly 4 p.m. right? Then I came here and ready to do this presentation and this lecture. Right, then I saw in the WhatsApp, right? There is a message from your representative, right? Normally I will conduct the lecture series according to the schedules, so no need to check day by day, right? Then if I want to cancel the lecture, right, then I will inform to you, right? Otherwise, normally the lecture will be conducted, right? No lectures will be available. If there is any incident, I will inform you. I am going to cancel today lecture, likewise today or tomorrow, maybe the relevant day. I will cancel the lecture. I will inform you, right? Then you can. I will inform to the representative. Then you can share that information. So no need to check day by day, right? No need to check day by day. If there is any cancellation of the lectures, I will be update you. And also, if from your side you are unable to participate for the lectures, maybe you have some kind of function or maybe some kind of work, or most of the students cannot participate to the lecture, then that kind of situation you can do some kind of request to me to cancel the lecture, right? Then if it is a considerable reason, then I can cancel the lecture, right? Because a lot of you cannot participate in the lecture, then I can cancel that one. So otherwise, normally the lecture will be on with the time schedule. If there is any change, right, we can discuss that one. We can discuss that one and change. Otherwise, normally the lecture will be available, right? So that is however I am working, right? Normally the lectures will be conducting in the time schedule according to the timetable. There is any changes, I will inform you from my side, right? Okay, that is some kind of information for you, right? Some kind of message for you. And let's start the session then, right? Then if there is some students that is waiting and also not participate or leave the meeting, ask them to join, right? Otherwise they will don't know that lecture was started, right? Because I think it was late around 20 minutes, right? Okay. Then I will share my screen, right? Right. Okay. Then we were discussing, I think you can see my screen, right? If it is not, please let me know. Then, right, then this is what we call as cloud computing. The introduction we are discussing, right? We are discussing about cloud computing overview, right? And we discuss about introduction, trends, distributed computing. We discussed those things we had discussed last days. Right. Then common properties of distributed computing. We discuss distributed and involve grid computing. Right. We discuss about grid computing and who use grid computing, type of grids, grids components. Then, right. I think we stop at this point. Right. Give me a minute. Right. Right. Okay. Sorry about that one. Right. Then we are going to discuss about what is cluster computing. All right. So we discuss about this, what is distributed computing, and we discuss about grid computing. And now what is we are going to discuss is cluster computing. Right. So what is cluster computing? Right. A cluster is type of parallel or distributed computer system which consists of collection of interconnected standalone computers working together as a single integrated computing resources. Right, cluster is type of parallel distributed computer system. Right, we discuss I think little bit about this parallel and distributed computing. Right, when we discuss about this parallel, right, normally parallel mean normally your computer is a parallel machine. That's the, as an example. For example, for that one, I can say normally while you are editing some kind of Word document, let's assume if you are editing some kind of Word document, parallelly you can listen to some kind of music. While listening to the music from the same computer, you can do word editing or spreadsheet work, right? So the computer is not performing a single task. It is some kind of parallel device, right? It can perform few tasks at the same time parallelly, right? So like that, right? Parallel distributed computer system, right? Distributed computer system, which is consist of collection of interconnected standard computers, right? Right, some kind of parallel or distributed computer system, interconnected, right, which is consist of interconnected standalone computers. A cluster means some kind of group of computer, right? It have this parallel and distributed capabilities. Both capabilities it has. That type of computing computer, what is called cluster or some kind of computer set, we can tell as a computer cluster. together as a single integrated computing resources. This is some kind of collection of interconnected standalone computers, but finally it works as a single integrated computer, right? We discussed a lot about this distributed computing, right? The parallel is, I think we might not much discuss, right? I think I explained something about this GPU, right? GPU, some kind of thing in the first lecture, right? GPU programming. This is some kind of example for this parallel computing, right? Also, normally the current microprocessors we have, Intel i5, or normally Intel, even Intel Pentium, they are also doing this parallel computations. Right. Key components of cluster include multiple standalone computers, right? PC workstation or SMPs, right? Right. SMP, right? SMP means some kind of processing technology called symmetrical multiprocessing, right? Symmetrical multiprocessing. That is some kind of processing technology, right? Right. Right, that is some kind of methodology for sharing the processor resources in the same operating system. That is what is this called this symmetric multiprocessing, right? Symmetrical multiprocessing means it is sharing the processor resources, right, inside the same operating system, right? So key components are these PCs in a cluster of a computer, cluster computing, or the cluster of computer, right? There is a collection of PCs, workstations, and some kind of SMPs, right? Right, some kind of programs, right? These are not software, right? This is some kind of software that is what we can use for this kind of cluster computing or parallel and distributed computing, right? That is the idea in operating system. To operate this kind of cluster computing, we need to have operating system, right? Maybe not normal operating system like Windows or CentOS, some kind of special operating system that was developed for these purposes, right? Then there is some kind of messages for me, right? There's a question: what is Ansible? I don't know. It's answering that one. Ansible. So Ansible, right? Ansible mean some kind of if you had, I don't know if you are working in the industry, maybe you will learn configuration management, some kind of configuration management tool. It is yeah, answer some kind of message from that is some kind of automation tool, right? Yes, we call it as normally the configuration management, right? Ansible, right? This is some kind of question answers are answered asked by your students, right? Your friends, right? Ansible, right? Ansible is some kind of configuration management system. Let's assume if you have some kind of server infrastructure, right? Let's assume you have 25 servers, right? 25 servers, 1, 2, right? 3, 4, likewise 25 servers, right? Then what do you want to do? Let's assume this is email server, this is what is this? This is web server, right? Likewise, you have 25 servers supplying different kind of services, right? Then what you can do, let's assume you want to install, right? You want to install some kind of software for each these 25 server machines, right? Then what you have to do, you have to take a pen drive or maybe some kind of devices, right? And go to this server machine and install that one separately, right? Go to here and you have to install, right? If you have some kind of remote login, then you have to remotely log into each machine and you have to install this software separately, right? You have to install this software separately. So that is a huge time wasting thing, right? Each of these 25 servers you have to install separately. Maybe you have to go physically. If you have some kind of remote login, you have to sit somewhere and remotely log into all 25 server machines and then you have to do installing, right? So this is example I am explaining, right? Then what you can do using Ansible, right? You can configure some kind of Ansible server, right? This is the 20, then you have 25 servers here. This is the 26th one, right? This is the Ansible server, right? Right? A server or Ansible server. Then you can configure this Ansible server to control the configurations in these 25 server machines, right? You can configure this A Ansible server. You have to install new server called as Ansible, and you have to configure this 25 server with this Ansible server to manage the configuration of this all of these 25 servers, right? Then what you can do if you want to install some kind of software to all these 25 server machines, what you can do within one command or maybe within one installation, you can deploy this software to all 25 server machines at once, right? At once, right? That is what we are calling as the basic idea of the configuration management, right? If you want to block some kind of software for is this some kind of website or some kind of thing in this, let's assume we want to block YouTube access for each server, right? Let's assume these are connected to internet. Then you want to block YouTube, right? Then what you can do, you can use Ansible server to give that configuration at once, right? You don't need to do 25 times the same thing to configure this 25 server machine. So you can use Ansible server to deploy. We are telling in technically, it is deploy, to deploy that configuration at the same time for all these 25 servers, right? That is the idea about this Ansible, right? There's some kind of another software called Puppet, right? Puppet, right? Ansible and Puppet, right? This, I think these all are open source tools, right? Ansible and Puppet, right? Ansible and Puppet, right? Right. How we are, right? Okay, okay. Ansible and Puppet, right? Ansible and Puppet. Okay. Then that is some kind of extra case, right? Extra case that some kind of questions asked by you, right? Some students are telling it is developed by Red Hat, right? Okay. Then right, we discussing about this cluster computing, right? Okay, I think we are done here in this slide. And right, cluster computing. Clusters are usually developed, deployed to improve speed and or reliability over that provided by a single computer. While typically being much more cost effective than a single computer, the of comparable speed or reliability, right? These are deployed. Deploy means we are installing or configuring this cluster computing for improve speed, right? If we are using cluster computing, we can improve the speed of the computing, right? Normally we have some kind of collection of computer to do the computing, right? So this cluster computing also have some kind of similarities with the grid computing and also distributed computing, right? But there are some kind of differences, right? Speed or reliability. Maybe reliability. If we had discussed this thing, right? Reliability means if some server is down, then another server is servicing you, right? So in cluster computing, normally if some kind of PC was down, then you can use some other resources, right? That will be improve the reliability of this computing, right? Over that provided by single computer, right? Then a single computer, we can gain this speed and reliability to the cluster computing, while typically being much more cost effective. It is some kind of cost effective method, right? This cluster computing than single computer. The comparable speed or reliability, right? It is speed is much high and the reliability also much high. Right. right? In typical cluster, right? In a typical, some kind of a classical cluster computer, right? Right? It is networking, right? Faster, closer connection than typical network LAN, right? So to establish a cluster computer, right, we need a fast network connectivity and closer connection than typical network, right? We need to have some kind of, that means geographically very close connection, right? Geographically very close connection to establish some kind of cluster. Otherwise, if the geographical distance, let's assume your one computer is in Sri Lanka, another one is in USA, right? This is USA and someone is in Sri Lanka, SL, right? Then it is geographically huge distance, right? Then if we are using some kind of network, let's assume it is internet, right? Then it is taking much time to communicate because of between this connection, there is number of routing stations, number of telecommunication companies, lot of bandwidth issues, lot of problems may be occur, right? So within this geographical distance, right, it is very it is not much compatible with developing this cluster computing, right? So we are normally choosing close distance and close connections to develop this kind of cluster computing, right? Then low latency communication protocols, right? Uh, right? Some kind of very low latency, right? Otherwise, the communication will be very slow. It is there is some kind of latency there. Sites then some kind of speed protocol, right? We are using to the communication purpose because without protocols we cannot communicate because these protocols are giving us the standard for the communication. So we are using some kind of low latency protocols for the communication purpose. And then right, some kind of it is loosely coupled, right? Right, loosely coupled than SMP, right? SMP, I think we discussed here, right? SMP, right? It is symmetrical multiprocessing, right? Then it is loosely coupled than SMP, right? Loosely coupling means, right? It is some kind of how can I say that one? Right? The normally the data rates, right? Some kind of loosely coupled multiprocessor system, the data rate is low rather than tightly coupled multiprocessor system, right? There is a thing called loosely coupled and tightly coupled, right? What is in this loosely coupled system? The microprocessor system, the data rate is low, right? The what I want to tell this network connectivity or this some the what I can say, right, in this processing, right, inside the inside the processor, right, there is some kind of processing path, right. So these paths are right very low, right. Speed is very low comparing to the tightly coupled system, right. I don't know what I think I don't know you understand what I'm telling here, right. The communication paths are normally slow, right. We are use this loosely coupled uh, right multiprocessor system, right. So then what is the case here then? In this case, right, if some kind of slow network connectivity, we can use this loosely coupled system. Otherwise, right, uh, right, there is some kind of connection issue, this cluster will be getting down, right. To mitigate that one, there is some kind of loosely coupled system we are using, or what we are telling it has a MTS, right, message transfer system, right. We are using for the communication between, let's assume this is two nodes, right, like this, right, two nodes, right. there's two nodes. Let's assume this is one computer in Colombo, this is one computer in Kandy, right? Then in this cluster, right, this is a cluster of two computers, right? Then, right, so they are using this loosely coupled technology. That means message transfer system for the communication within these processors, right? So if you are not understand that one, right, don't think much, right? Okay, that is the cluster computing, right? Then types of clusters, right? What are the types of clusters that we have? Then first one is I am not discuss much deep, right? Those things, right? There's some kind. I will give you a little introduction, right? High available, right? High available or failover clusters. That means these clusters are designed for the high availability, right? In your network infrastructure or the system, these clusters is the main purpose of, let's assume, a website, right? If like some kind of website, you need to available this website most of the time, right? The downtime of the website need to be very low. Then it is some kind of high availability of failover cluster. That means if some server or some devices is down, then some another devices available in the cluster will be came to the system and running on behalf of the down system, down devices, right? Down devices. So that is the idea, right? That is we call as high availability of failover clusters, right? Then next one is load balancing clusters, right? How we can balance the load, right? Then let's assume this website, there is a 10 million, right? 10 million responses or the request per second, right? This is some kind of highly busy or the highly trafficked website, right? Then you need to use some kind of load balancing technologies, right? For implementing that one in this cluster computing, you can use some kind of separate clusters. It's cluster 1, right, 2 and 3, right? 1, this is 1, 2, 3, right? You can put some kind of routing mechanism here, right? This is routing mechanism. This is maybe routing mechanism, or we can say this as the load balancing cluster, right? All requests are coming to here, right? Then anyone want to access this website, all requests are coming to here and there, right? Here and there coming to here, right? Then what this router or this load balancing cluster is doing, he is identifying what are the free places that we can supply the service, what are the low busy places or low busy clusters, and according to that, he will direct these users to here or here or here, right? That is the idea about this load balancing clusters. So this cluster is balancing the load that is coming to that node or that load balancing cluster, right? This one is balancing this load and sharing this load between these three clusters who is producing or who is the production clusters, right? This cluster is this router or this load balancing cluster getting 1,000 million requests per second, then it is the load balancing cluster and it is managing these three clusters who is supplying service, and the customers or the request is directed by this load balancing cluster, right? That is the idea about this load balancing cluster. And then parallel and distributed processing cluster, right? So you know what is distributed computing now, right? So also I discuss about parallel computing, right? So also there is some kind of this kind of clusters is available for this parallel and distributed processing clusters, right? This kind of mechanism also can implement that using this cluster computing, right? This is some kind of idea or the three types of clusters, right? High availability and failover clusters, load balancing clusters, and parallel and distributed processing clusters, right? Then some kind of components. What are the components that we have in a cluster, right? Then basic building blocks of cluster are broken down into multiple categories, right? Cluster nodes, cluster network, and cluster characterization, right? So this is some kind of simple information, simple informative graph that you can take some kind of idea, right? Then this is the thing that I had discussed here, right? This is some kind of, I call this as a router, router or switch, right? Maybe switch, right? Anything, right? Or maybe this is some kind of routing load balancing cluster, right? So these are the nodes in the cluster, right? Right, this is the nodes. Maybe these are the participants in the cluster, right? Computer one, that means node one, node two, right? Likewise, these are the clusters that is available, and this is the switch that these clusters or this sorry, these nodes are connecting through this switch to the main network or the main cluster, right? Likewise, this is one part, right? This is one part, one, right? One block, right? In the cluster, another blocks like this are available, right? This is the first block and this is the second block, right? Another third block, right here, right? Third block, right here, fourth. Likewise, the cluster components, right? These are the major components, right? This is the basic building block of the cluster, right? This is the basic building block, right? So then, right, inside that we can also divide into nodes, switch, and this kind of connectivity, right? So collection of this all kind of system we can call as a cluster of computing, right? Right, then these are network links, right? These are network links. These all are, these lines are not denoted the cluster networks. And this is some kind of switch. If you are networking, you know what is switch, duty of the switch. This is the idea. This is not that kind of switch. This is the idea of the switch, right? Okay, then that is the some kind of components, nodes, switch, and these network connections, and some kind of network characterizations are there, right? So that is the idea. Right, then we will not discuss deeply about this cluster components or cluster computing, right? Then we will directly discuss some benefit of clustering, right? What are the benefits, why we need clustering, and what are the advantages we can take from this clustering of the computing, right? Computers, right? Then system availability. First one is system availability. We can guarantee, we can give a guarantee that the system will be, the system downtime will be very less. The system downtime will be very less. That means the system will be highly available, right? Of a inherent high system availability due to the redundancy of hardware, right? Redundancy of hardware, operating system and application, right? Normally they are using in clusters, you know, redundancy. Mean if you, I don't know if you are learning about this redundancy of hardware disk, right? RAID technology, right? RAID, right? This is the idea is the name is redundant array of independent disk, right? The redundant array of independent disk, right? Redundancy, right? This is some kind of mechanisms that how we can improve the redundancy of the hardware or the storage devices. Hardware means hard disk. How we can improve the redundancy of the hard disk or the storage devices. This is some kind of concept, right? We can discuss, right? I think maybe you had learned this RAID technologies, right? RAID 10, RAID 1001, likewise, there is a number of things, right? RAID 0, RAID 12, likewise, right? Then, right, I am not going to discuss about this RAID, right? However, that is some kind of redundancy technology, right? So this system availability, right? Redundancy of the hardware, right? Normally, in some kind of system, the hardwares are normally falling, right? Right. Then, for example, again, then you have stored your images or your detail in the Facebook, right? Images in the Facebook, right? Then it is having some kind of server machines to store your data, right? In that server machines, the storage devices are right? Normally the hard disk, right? Storage devices are hard disk, large size of hard disk, right? Normally, in a normal computing, a normal computer, the hard disk or the HDD or the storage devices are getting failed, right? Sometime maybe you have experience in your computer, your hard disk is not working. Then what happened? The data is stored in that hard disk are lost. If you are not putting any some kind of backup mechanism, backupping of that data, the data will be lost, right? But you know that in Facebook, right, they are using some kind of same hard disk to store the data or your images, maybe your information, right? They are using same type of hard disk, but there is no failover, right? Normally, there is no information loss in the Facebook servers. So what they are doing, they are maintaining some kind of high redundancy hardware infrastructure, right? Without without losing of any data, right? They are trying to maintain their infrastructure, right? So you can imagine how much their infrastructure is strong and reliable or redundant, right? Then when you upload some image into the Facebook, right? I think if you upload some images into Facebook before 10 years, still it is available, right? Normally we know a hard disk it is not working or not functioning 10 years, right? Normally 5-6 years, after 5-6 years, it will be not working, right? But your image in the Facebook is still available, right? That means they are maintaining. Normally, I know in the server farms, their number of hard disks are failed into a day and they are replacing them, right? But they are developed some kind of mechanisms to back up this data, or maybe they are using some kind of redundancy technologies for the hardwares, right? Especially for the storages, right? That is the idea here. Right? In cluster computing, we can also, using this cluster computing, we can improve this redundancy of the hardware, right? And operating system redundancy. Maybe Windows crashes, right? The operating system crashes, maybe with Windows, especially in common in Windows updates, you got operating system crashes. Then all of your data stored in the operating system cannot be accessible, right? So we have to we can fail over, or we can mitigate this kind of things using this kind of cluster computing, right? And also application. Maybe you are working with some kind of, let's assume, CAD software, CAD project you are working, then your data are stored in a computer application, inside the computer application. Then what happened, due to some issue, the application is not working, right? Then your project will be lost, right? Then in this cluster computing, we can mitigate this kind of issues, this kind of data losses, right? That is the idea here, the system availability. Hardware fault tolerance, again, the same idea, right? Fault tolerance, right? Redundancy for most system components. Example is, right? Here, RAID is mentioned, right? Redundancy of most system components, right? Maybe this RAID, including both hardware and software, right? Maybe I am not going to discuss about this RAID technology, right? Redundant array of independent disks. Redundant array of independent disks. I'm not going to discuss, but I think you had learned, right? Especially networking people, right? It is very important to learn, right? Components, including both hardware and software, right? We have to use some kind of fault tolerance mechanisms, right? Using cluster computing, we can do some kind of fault tolerance mechanisms like backupping, or maybe time to time resource sharing, or maybe keep extract copy of data. Likewise, we can use some kind of mechanisms in cluster computing, right? Then OS and application reliability, right? OS and application reliability. This OS and application are much reliable, run multiple copies of the OS and application, right? Then it is some kind of cluster you can run multiple copies of the operating system, right? You can run multiple operating system. Also, cloud computing, you can run multiple operating system. We will discuss those things few upcoming sessions, right? Of the OS and application, right? Or also, you can run multiple applications inside this cluster computing system. And through this redundancy, right? Also, this redundancy is also available. So you have a guarantee that the data or the thing or the applications or some kind of information that you had stored in your cluster is available for your usage within low uh, disruption or very low destroyed, very low, what I can say, very low less, right? Very low less situation, right? Otherwise, this data loss can be happen. We can mitigate the loss of the data, right? Right, in this cluster computing, right? Then the scalability, right? Scalability. Then what is the scalability mean? Adding servers to the cluster or by adding more clusters to the network as the need arises of CPU SMP, right? Right. Then for the small multiprocessing system or the multiprocessing mechanisms or the algorithm, then you are processing this process. If you need more processing power to the calculation, right, you can improve the processing power or the resources by adding more servers, right? If you want, right? If you have, let's assume you have 10, 100 GB RAM memory, right? But you want more for some kind of reason. Then what you can do, you can add some kind of server machines. Let's assume another server machine that is consist of 50 GB RAM. Then total will be 150, right? You can add to your cluster, right? That is some kind of benefit of this cluster computing. You can add, right? Or maybe adding more clusters to the network, right? Then you have a cluster computing network, right? Then what you can do, right? Then you can connect another cluster, right? Like UOVT, right? UOVT having a cluster computer. Then you have for some kind of research, you need a huge computing power. Then what you can do, you can connect this UOVT cluster with some other cluster like Kelaniya cluster. Let's assume, right? Kelaniya University cluster, right? You can connect, right? So from this, you can improve the cluster computing, right? You can improve the computing power or the RAM memory of this your cluster computing network, right? Or here for the scalability. That means for the scalability, you can do two things. One thing is you can improve the server, or maybe you can connect any other cluster, right? Okay, that is the idea here. Then high performance running cluster enable programs, right? Then you can gain high performance because this is some kind of huge computing power and huge storage you can make or you can manufacture, right? You can create using this cluster computing, right? Okay. Then that is the right. Then we come to another new topic, right? Utility computing, right? Okay. If you have any question in this cluster computing, you can ask, right? Right. Otherwise, if you don't have anything, we can move to next one, right? I will give I think 30 seconds to ask if you have any question. Right. Okay. Seem to be there's no issues, right? Then the next one is utility computing. Right. Then so far we had discussed about distributed computing and grid computing and cluster computing, and now we are in here. Right. Now we are very close to our topic, right? Right. Utility computing, right? So these are almost some kind of common concept, right? There are interconnection between this concept, right? That's why we are discussing all of this, right? Not in detail, up to some kind of introductory level, right? Introductory level. So then utility computing, right? Okay. Right. Utility computing, right? Utility computing is purely a concept which cloud computing practically implements, right? So this is now we are coming to this cloud computing, right? Little by little we are coming to this cloud computing. Utility computing is purely a concept which cloud computing practically implements, right? So this utility computing is the idea, right? How we use this cloud computing, right? This is the main idea inside the cloud computing, right? So actually how uh, that is a concept according to this, right? The utility computing is the concept. How this is some kind of sub part of the cloud computing is a sub part of this utility computing actually, right? Right? Utility computing is a service provisioning model in which the service provider make computing resources and infrastructure management available to the customer as needed, right? And charges them for specific usage rather than flat rate. Service provisioning model, right? So this utility computing, it is servicing you, right? It is giving some kind of services to you, like in Sri Lanka, electricity board is giving power to you. Likewise, some kind of company is giving you maybe computing power, maybe online services, right? This is some kind of the idea of this utility computing model in which service provider make computer resources and infrastructure management, right? This service provider, right, is making or supplying computing resources. It is he is or the service provider is providing computer resources, and also right, infrastructure management available to the customer as needed, right? Also they are supplying infrastructure, right? Infrastructure, that means if you want to host a website, they will give you space or the server machine inside the internet, right? That is the idea, right? Infrastructure management. If you want to manage the infrastructure, you can request them to, I want the control of the infrastructure or the management of the infrastructure, then they will give, right? The customer as needed. If customer want, they can request and charges them for specific usage rather than flat rate, right? Then there will be some kind of charge or the payment that will be available for the users or the consumers according to their usage, right? According to their usage, has the advantage of a low or no initial cost to acquire computing resources. Instead, computation resources are essentially rented, right? This is some kind of renting, right? Renting of computing power, computing resources, all this networking, or still all these things, or maybe technology also rented, right? This model has advantage. This is advantage of low or no initial cost, right? Because you are going to rent all this thing, all your infrastructure is going to rent, right? Then you are going to pay the rent according to the monthly usage, right? That kind of concept is utility computing, right? No initial cost to state computer resources are initially
Recording in progress.
fixed cost for the month, but if you exceed the limit, you have to pay according to the level that you had used, right? That's seeks to meet fluctuating customer needs and charge for the resources based on usage, right? It will be charged according to resources that you had used rather than on a flat rate basis. This approach sometimes known as pay per use, right? This is the idea about, we know, right? Pay per use, right? Whatever the thing you had used, then you can pay for that one, right? That is the idea about this utility computing, the basic idea. Right. Then next one is utility computing. What is utility computing, right? Utility computing, this is some kind of another idea, right? Utility computing has usually envisioned some form of virtualization, right? It is some kind of virtualization, right? You don't have actual hardware or the server machines, right? But you are using it, right? That is some kind of form of virtualization. So that the amount of storage or computing power available is considerably larger than that of single time sharing computer, right? If you want to make a server room and you want, let's assume if you are not going for some kind of utility mechanism, or you are planning to, if you want to deploy a website, then you are planning to make all the infrastructure. Then you have to purchase server machines, you have to purchase softwares for that, then you have to purchase or get internet connectivity for that, then you have to take public IP address for the website, then you need engineers for configuring it and for the maintaining it, updating it, right? So then it is huge, a costly approach, right? But in this utility computing mean, you will get some kind of these resources from as a rent, for the rent, right? You are renting the resources. Then the initial cost for acquiring this website will be very less, right? Very less in this utility computing, right? That is the total idea of this utility computing, right? So, right, shall we take few small break, right? Small break, shall we take? Right, any idea?
Okay, sir.
How many time?
We'll take 10 minutes.
Okay, 10 minutes or 5 minutes?
You can decide, sir. You are lecturer.
No, it is okay. However, okay, according to your requirement, then we will not 10 minutes, right? We will start at 6, right? Then it will be 8 minutes, right?
Okay, sir. Sure. Thank you.
Sure. We will start at 6, right? Wide idea about this utility computing. Pay for use pricing business model, right? This is some kind of popular business model that we have. Pay for use, right? What was the thing that you had used? You had to pay for the pay for your usage, right? So in this utility computing, what is the computing power, processor, hard disk, or user networking you had used according to that utility model, right? We have to pay, right? And then data center virtualization and provision, right? You know, when if we want a server machine for our works, then we can hire a virtual server from their data center, right? Then you don't have any kind of server machines to hire some kind of virtual server, right? Then you can pay and you can hire and you can do in whatever the thing you want. If you want to develop software inside that server machine, you can develop, right? You can develop software, and if you want some kind of website hosting, or maybe some kind of LMS hosting, some kind of web application like maybe Facebook or Google Workspace, likewise some kind of, maybe let's assume some kind of what are the services, online service, some kind of online service you want to establish in the internet, then you can use this virtual servers, right? And provision, right? Also, slow resource utilization problem, right? Then if you have any issues when using resources, then you can use. What is the advantages of this utility computing, right? Then your virtual server has, let's assume the hard disk storage is 1 TB, right? Let's assume it is 1 TB, right? Then suddenly for your website is, this is assume server for this 1 TB storage is in a server machine that is you are using for the your website hosting. For your website hosting, you are using this 1 TB server machine. Then suddenly there is number of users and number of comments and number of responses from the users, and suddenly you need to increase this one, right? Then you need, let's assume you need to go for the 2 TB, right? Then what you can do, you can easily request for the service partner, the service provider, to, I want another 1 TB, please improve that one, I will pay. Then what he will do, in this virtual machine or this virtual server, that service provider will increase your memory, right? Then you have to pay for 2 TB, right? Monthly or weekly, or according to the payment scheme, you have to do the payment or in 1 to the 1 TB, right? Then it is very easy, right? You no need to do any configuration or anything. The service provider will provide those things. You have to only pay this thing, right? That is the idea. So you can utilize these resources, right? Or there will be no problem about this storage or any other thing, right? RAM, even processing power, you can hire it, right? Then outsourcing, right? It is some total idea about some kind of outsourcing, right? Outsourcing of that means let's assume the largest that is some kind of cloud service provider, right? Let's assume AWS, right? What they are doing, they have some kind of infrastructure all around the world, right? They have some kind of infrastructure all around the world. What they are doing, they are renting those infrastructure, right? That means outsourcing, right? They are renting, right? They are renting this infrastructure and they are obtaining money, right? They are gaining money, right? They are now a very rich company, right? Very powerful company in the world, right? So because of this outsourcing, right, of their infrastructures, now it is some kind of business now, right? Normally in our villages we have some kind of people who is outsourcing things, right? ගෙවල් හදන්න බඩු දෙන කට්ටිය ඉන්නවා, right? Likewise, this is some kind of business like that, right? But they are outsourcing IT infrastructures and IT services, right? Then web service delivery. Normally, a lot of these utility computing things or these virtual machines, these are deployed or servicing to the web-based service architecture, right? Through web server or web interface, this resources or the virtualized machines will be deployed. That means you can access these resources using some kind of web interface, right? It is that's why it is mentioning as web services delivery, right? Right, and some kind of automation is there, right? Then we discuss about some kind of not automation, of some kind of we discuss about Ansible, right? Some student goes ask some kind of question, Ansible, right? Then that kind of thing we can do in this kind of virtualized server infrastructure. Let's assume you have 10 virtual servers in some kind of infrastructure, then you can configure some kind of automation, right? Automation means if you want to, let's assume you have a website, you need to back up this website every day, 11 p.m. Before midnight, you need to back up. Normally we are maintaining, right? So then what you need to do, some person need to log into website portal, some administrator, and he need to back up that one, right? So every time at 11 p.m., right? So it is very stressful, right? It is not practical, right? Then what we are doing, we have some kind of mechanisms for automating this one, right? We can use shell scripting or maybe some kind of scripting language, right? So we can use especially shell scripting, right? And in bash shell we can use for this kind of automation purposes, right? So here in this virtualization, right, without doing that manual configuration, normally some cloud providers or the utility providers, they are providing this automation as their service, right? Automation, if you want to back up your website, this service provider will provide some kind of small function to back up this. You back up your website, right? Back up your updated website, right? So that is mean this automation in utility computing. All right. Then utility computing example, right? Utility computing example. This is some kind of graphical representation, right? Then this is scientist, right? This is scientist, and this is some kind of virtual machine cluster, right? And this is virtual machine repository, right? XC server, right? And on-demand web service. Maybe this is scientist or maybe some kind of user, right? No need to be a scientist, right? Let's assume this is some kind of user or maybe administrator, right? Administrator or maybe someone, right? Right? Then what happened? He sent the step one is he will send some kind of request to some kind of web service, right? On-demand web service, right? This is some kind of machine or the service. There will be some kind of server machine here, server infrastructure behind this. Then you are sending a request to here. So you want to do some kind of calculation as a scientist, right? Then you send some kind. I want to do this calculation. You are sending that request to this. You are dealing directly with this on-demand web service. You log into your web interface through the web browser or some other way. Maybe a lot of time it is your web browser. Then you are accessing this on-demand web service and you are sending that request. Then what happened, right, as the second step, this request, right, this request is passing to this virtual machine repository and also this XC servers, right? Right. This virtual machine repository, this is some kind of server infrastructure, right? This is some kind of servers, not only one, maybe collection of servers, lot of time. It is some kind of repository means storage, right? Repo, we call technically a repo, right? Just short word, right? Repo is some kind of repo that is storing data about virtual machines. This repository is storing data about virtual machine. He know where the virtual machine clusters are available. He know where is the place or where is the IP address or where is the location that the certain virtual machine is available. Right? He have this kind of detailed information. We call as some kind of repository he is maintaining. Right? Then also the same request is come to SE server. Right? This is some kind of SE server means some kind of hypervisor. Right? That is we will discuss this about this hypervisor deeply later. Right? This is some kind of hypervisor developed by the company called VMware. Right? Right. It is using for the as a basic serving what we call basic it is serving for the virtual computers, right? So between this virtual machine repository and this XC server, right? Right, this is some kind of servicing infrastructure, servicing server, right? Then from here, as a number 2, the same request is come to here, and this virtual machine repository will be find some kind of virtual machine cluster for you, for your request, your calculation, your scientist calculation. Then it will be passed to here, this SQ server. Already this SQ server know about this request. Then what finally that one is doing, the request is forwarded to a certain virtual cluster that is available and that is enough, that is having enough power and computational power and enough memory to do your calculation, right? It will be passed to some kind of virtual machine cluster. Maybe some clusters are available here, right? This is cluster 1, cluster 2, cluster 3, right? This virtual machine repository is deciding according to your work what is the place you need this calculation need to be passed. According to this virtual machine cluster or this place, second cluster, this is the second cluster and this is the third cluster, this is the first cluster. This virtual machine repository will be deciding what is the place that this request need to be passed. This request need to be passed, right? That is the idea, right? Virtual machine cluster, right? Okay, that is this some kind of very less explanation about this on-demand cyber infrastructure, right? In utility computing, right? Then some kind of informative thing, right? Some kind of information about this is some kind of thing. Comparison, I can say comparison, or maybe some kind of information about this utility solution, right? Some kind of perspective about this utility solution. Then consumer was provider. This circle is consumer, and this circle is provider, and this is some kind of a mixing of this consumer and the provider. Right, then from the consumer, that means the user. Consumer means user, right? Like you, right? You and us, right? Consumer. When you are going for some kind of utility solution, right? Utility solution, you need to think about the service procurement, right? How you can, procurement. If it is government, there is huge rule for the procurement, right? So how you can acquire or the procurement, that means this acquiring stage, that means how you can do the payment, how you can find provider. Likewise, consumer have to think, right, and take actions to find some kind of provider, right? That is the service procurement, right? And then service assurance, right? We need to find some kind of good service provider, some good utility, or maybe cloud service provider. Otherwise, what will happen, right? If your valuable information is stored in some kind of server machine, then suddenly that company will be vanished, maybe vanished, right? Some company may be vanished, right? Then what happened? Your data, your industry, maybe you are some kind of a huge company doing a lot of businesses, then your data, your information may be stolen, maybe robbed, or maybe lost, right? So you need to think about service assurance about your consumer, right? Then the availability. If you are using your, let's assume Cargill Food City, they have some kind of information systems. When you are paying your money, then that system will be need to be available for you, right? Normally they are requesting for the loyalty cards. Loyalty cards they are requesting. So that time, that's this all branches are connecting to a same network, right? So that one, there will be the network availability will be there, right? Card එක ගහනකොට වැඩ කරේ නැත්නම් වැඩක් නැහැ, right? Likewise, right? Normally this availability, right, need to be there, right? I know this HNB Bank, in their online payment system, they are using AWS, right? Amazon Web Services as their utility or the cloud service provider, right? Then in utility solution, contractor management, right? Then from your side, your consumer side, the contractor need to be managed. Otherwise, he will be not servicing you. Maybe he will not agree, or he will destroy the agreement. Likewise, this kind of situation that will be happen, right? So you have to properly manage or communicate with the contractor or the service provider. Contractor means the service provider, right? You have to work with him. And also this consultant. Consultant means who has expertise in this utility solutions. You have to take consultation from that kind of person. If a company don't have internal expert in the area, then you have to outsource the consultant, or maybe you can hire a consultant to your organization, right? That is the total idea in this consumer side. Then if we go to this provider side, right, then infrastructure procurement, right? Then how you are going to procure your infrastructure? What is the cost, right? If you are what is the payment or the price for 1 TB hard disk storage? What is the price? You have to define with your cost and the pricing margin, pricing and your profit margin. You have to decide what is the value, what is the price we are going to sell our infrastructure, right? That is the idea. And what are the rules and terms and conditions, maybe rules and regulation that you need to give for your consumers, right? As a provider side, maybe you have to think, right? Then equipment maintenance, right? How you are going to maintain your equipment. I discussed earlier about the Facebook. Your images are still available if you upload that image before 10 years, right? I have images upload before 10 years, but still that images are available, right? But the equipment are destroying, hard disks are changed, but your infrastructure is available, right? So you need to think as a cloud service provider, you need to think about equipment maintenance, how you can maintain your equipment, right? Otherwise, this will be some kind of issue, right? Equipment maintenance. Then next one is resource utilization. All right, how you can utilize your resources. Maybe you have huge resources. If you are not utilized or properly manage these resources that you have, let's assume you have 1,000 terabyte storage, right? Then you have to manage this resources, right? Resource utilization means that, right? You have to manage these resources. Otherwise, this will be misused or maybe not much effectively using, right? So resource utilization need to be done. Then technology refresh, right? You need to continuously update your infrastructure according to the current available technology. You know, the available technologies are changing rapidly, right? Especially this IT industry. And the ICT industry and IT industry, or the computer science field, IT industry, we call it is IT industry. It is vastly changing industry, right? Technologies are time to time changing, right? So you need to refresh your organization, right? According to this new technology. Then system admins, right? You need to have a loyal, you need to have a knowledgeable and skillful system admin. That means engineers for your working place, for your infrastructure management. Otherwise, the some kind of downtime, corruptions may be available, then it will be not a good image for your organization, right? Then capacity planning, right? According to the capacity, you have to plan. Capacity planning means this is very important concept, right? These are very important concept, right? Then I know Facebook, that's again a Facebook we take, right? Now you know people uploading videos, images, a lot of people newly joined to the Facebook. Likewise, right? Then they need to expand their infrastructure, right? So then they need to plan their capacity, right? Otherwise, if they don't plan today, the capacity, within 5 years, the storage will be not enough for them, right? Or the bandwidth will be not enough for them, right? Then it will be degrade the service. So that reason, they have to do capacity planning as a service provider, right? So this both of these people, consumer, that means the user, the provider need to think about this thing, right? The pricing, right? The both consumer and provider need to think, right? If it is consumer need to think it is a low price for us, it is advantage for us or not, right? Likewise, provider need to think about pricing and what is the profit margin he need to define. And they have competitors, right? Providers, they have competitors, right? So contrary to that, they have to fix some kind of price margin, right? Right. Then the security, right? Both need to think. They need to think about their information security and their service security. And also this provider need to think about the security. Otherwise, if there is some kind of information leakage or any problem occurs, then the consumers or the customers will be unsatisfactory, right? Unsatisfactory about your service, right? Unsatisfying about your service, and then the customers or the consumers will be withdraw you, right? They will be moving from you. Then the business will be getting down, right? Then you have to think about this security. And this is the SLA mean, what is that SLA? The service level agreement, right? So we will discuss about that one deeply, right? This is some kind of agreement between the cloud service provider and the customer or the consumer, right? Agreement between a cloud service provider and the consumer, right? This is we call as service level agreement, right? According to this, all the things that we need to clarify here or need to be discussed here need to be included in this service level agreement, right? The consumer side and also both provider side, and both need to be signed for this service level agreement. Then how this utility solution is or the cloud solution is can be utilized or using between this consumer and provider, right? And then applications sizing, right? What are the application or the size of the application you are going to run in this infrastructure? You need to have idea. Both consumer and provider need to have idea. අපි ගන්න website එක දුවන්න, right? Then they need to have some kind of idea. Otherwise, then this is a simple website, no need huge infrastructure. But it is some kind of, some kind of huge like LMS server, right? Then it is coming huge request. Then need to be some kind of powerful infrastructure, right? So both need to have this idea, application sizing, right? So that is some kind of perspective, right? About consumer and provider. Then a little bit discussion about this, right? What is a payment method? How payment models, right? What is this payment models that we have? Same range of changing models as other utility providers, right? Same range of changing model as other utility providers like gas, electricity, telecommunication, water, television broadcasting, right? Gas is now problem in Sri Lanka, right? Electricity also problem, right? These are some kind of popular concept, right, in the world, right? I think who is invented the electricity? Michael Faraday. I don't remember the scientist. Somewhere in the Germany, right? Maybe Michael Faraday, or I don't remember, right? who was invented the electricity, right? Then he told, when he found this electricity phenomenon, then he told that to the other scientists, that there is 3 scientists that is working with this research, right? Unfortunately, they are doing some any other thing, but unfortunately they found this electricity, right? Then what they had decided, Michael Faraday was the scientist, as I remember, it is Michael Faraday, right? Faraday is told, we no need to introduce this electricity to the general public, right? We no need to introduce this one to the general public, right? Then the reason he told that the reason is, this is very, right, this is very much of destroying of the energy, right? That means, let's assume we are generating power through the diesel, right? Then let's assume here, right, we have 100 joules, right, in this some kind of 100 joules of energy. Joules is correct, neither joules of energy inside this diesel, right? This is some kind of diesel can, right? Let's assume it has 100 joules, right? Then after transferring it to electricity, right, then it will be nearly 40%, right? 40%, right? 40% mean, I will write like this, only 40 joule, right? 40 joule is converted as electric power, right? 60% or the 60 joules were lost, right? In this conversion, diesel to electricity conversion, right? Then while transmitting this electricity from the generating station or the power station to our home, then another 5 to 10, right? 5 to 10 is lost, right? Then finally from this 100, right? I think this is 5 to 10%, right? That's right. Then if we take 5, right? Then another, let's assume this is 5, right? Then 35 is coming to our home, right? This is what is coming to our home from this 100, right? Then when we are using some kind of electronic device, right? It is some kind of it is that device performance may be 40% or 30%, right? Again, another 40% or 30% will be lost, right? Then finally you will lose nearly somewhere around 20 joules, right? From this 100 joule from diesel, right? So in this process, there is huge energy loss, right? That's why who is invented this electricity, right? Who was invented this electricity is telling, we no need to introduce this to the general public. Right? This is based in the energy, right? So I told this story. This is some kind of scientific story, right? So that's what I tell in this one. Now we have an electric problem in Sri Lanka, right? I know you are also falling. I am also fed up with this situation, right? So however it was introduced, right? However, but Michael Faraday, maybe my Faraday was not like, but others are not agree. Then they introduced, right? Then electric is coming to the human civilization, and all other things are now depend on electricity, right? So it is some kind of the huge, I don't know, it is some kind of change in civilization, right? Right, we be discussing about, right, is some kind of another story, right? We're discussing about this utility providers, right? Gas, electricity, also telecommunication, internet and telephone, call and SMS, these services, and also water. You know, water is some kind of thing. Now also television. Now we are paying for the television broadcast in air, right? Dialog TV, any other SLT, right? Likewise, right? So same range of charging models, right? We have payment models in this utility computing, like this gas, electricity, telecommunication, water, television. We have some kind of same payment model. Flat rate. Flat rate means you have to pay whatever the flat rate, right? Whatever the how much you had used or no, there is a flat rate, Then next one is tired, right? Tired mean pay for only this service feature of the quantity, right? Or only for the some, if you are using some kind of subscription based, right, thing, right? Some kind of whatever the thing you had used, right? Maybe let's assume if you are like electricity bill, if you are using 60 units, then some kind of price, right? If you are using 90 points, then the price, whole price will be getting up, right? Likewise, that kind of higher model, payment model, right? Then the subscription, right? Then maybe you know subscription model according to the services. You have service wise, you have to pay. Then you are using Gmail, then you have to pay for the Gmail. Likewise, right? Then you are using any other services in Google Cloud you are using, then you have to pay for the Google Cloud. Likewise, there's some kind of subscription, right? Also, this free and open source software, we have this kind of subscription model, especially in the CentOS, kind of operating systems are free, especially Red Hat operating system. They are charging for the services. Operating system is free, but they are charging for the services that they are supplying, right? So that is some kind of subscription model. That is the idea about the subscription model. Then the meter, right? Then you know metering, right? Metering, water meter, right? Electricity meter. According to the metering, you have to pay, right? Then pay as you go, right? Then there is no limitation. This pay as you go mean like some kind of prepaid connections, right? Prepaid connections. You are paying and you are using, right? No limit, right? Likewise, right? Normally in this metered connection, there is some kind of limitation there, right? Especially in telecommunication. For the postpaid connection, you have some kind of limitation. But here, no, right? Pay as you go, right? And some kind of standing charges, right? Some standing charges mean normally it is a popular standing charges method is daily charging, right? Like dial-up per day TV, right? Some kind of like that, right? You have some kind of fixed rate for a day, right? Day by day you have to pay, right? Like this is some kind of simple idea about this payment method also in this utility computing. Then different pricing models for different customers based on the factors such as scale, commitment, and payment frequency. According this pricing models will be differ according to this kind of factors like the scale or the infrastructure that you are using, or the commitment, or the then you are paying this price correctly with the monthly basis or according to your payment, according to your payment structure. Then according to commitment, they are giving bonuses, right? Likewise, they are giving some kind of price reducing, like some kind of thing. That is this model will be depend on this commitment and the payment frequency. Maybe you are paying daily or monthly, or according to you, maybe weekly or maybe yearly. According to this frequency, the payment model will be different. But the principle of utility computing remains. Right? This is what the principle of utility computing remains, right? The basic principles, the basic principal ideas, the principal concept of utility computing is still remain. However, you pay, it is not depend, right? The pricing model is simply an expression by the provider of the cost of provisioning of the resources and profit margin by the provider. It is some kind of expression of or the cost of provision of the resources and the profit margin, right? The total payment may be, right? Total payment may be equal to some kind of cost of the provisioning, cost plus the profit margin, right? Profit margin of the service provider, right? That is the idea here. That's this sentence, right? So pay equal cost plus profit margin, right? Cost of the service providing and profit margin. This is the totally pay that we have to do. Right. So that is the idea. And risk in a utility computing world, right? We have some risk, right? We have risk. Anything we have risk, right? First one is data backup, right? So we need to use some kind of backupping mechanisms in the utility computing. Otherwise, normally it is very less. Now the popular service providers are the downtime will be very loss, and the data loss will be very less, right? But maybe it can happen if it is better if you have some kind of internal infrastructure, you can back up this data, right? And the next one is data security, right? About you have to think about security, right? In utility computing also. So various, it is a vast area, right? Data security, right? Or the information security or the network security, right? These are the vast area, right? Now these are the area now highly paid, right? Highly paying positions in the industry, security, right? Data. So it is a very vast area, right? Oh, I think more than programmers, right? More than programmers, the information security officials are getting paid, right? Now today, right? This is very popular area now, right? Popular mean very critical area, that very important area. That's why they are paid, right? Because this information security need to be managed, right? The security risk is available in this utility computing. Then partner competency, right? Then what is who is the service provider? He is competency with this service. Maybe normally when we are going for some kind of procurement with the company, we are checking what is this company history. If it is less than 10-year, the history of the company need to be at least minimum 10 years. Likewise, we have some kind of conditions when we are going for some kind of procurement. Otherwise, we are not offering these services for them, because if we think at least in we are considering 10-year time mean, we can think that this company is doing good business, good service, or the technological expertise in that certain utility computing area, right? Otherwise, that will be issue, right? If we are not going with the competency company, right? Then also the partner, sorry, about the defining of SLA, right? Service level agreement, right? We will discuss this one about, right? How we can define a service level agreement in utility computing and also cloud computing, right? We will discuss this one, right? So how we can define agreement between the consumer and the service provider, right? What are the conditions, right? Then getting value from chargeback, right? Then if we are using utility computing from some kind of user or cloud computing, then how we can take, then we have to pay monthly or some according to some kind of payment scheme. This is some kind of this payment scheme we have to pay. Then we need to think how we can earn from that investment, right? This is some kind of investment. We are investing on utility computing power to hire the infrastructure. Then we need to think how we can getting value or the profitable, right? How we can take profit from this business, right? That is the idea, right? Then our topic, right? Again, the cloud computing. Now we discuss about this what is the thing, distributed computing, grid computing, cluster computing, right? Utility computing. Now you have idea here. Now this cloud computing have some kind of mix of this concept, right? All this distributed computing, grid computing, cluster computing, utility computing, this cloud computing have some kind of mix, right? It has this all characteristics. Someone is less, someone may be high. So it is some kind of a combination of these technologies, right? So then we go to this topic, right? Cloud computing. All right. Right. Then some kind of definition, right? US National Institute of Standard and Technology, right? US National Institute of Standard and Technology define computing as, right? This is some kind of institution who is defining standards, right? Some kind of Sri Lankan standard institution, right? SLS likewise, right? Some kind of, right? This is not like that, right? This is some kind of reputed organization, right? So the cloud computing is a model for enabling ubiquitous, right? Right? This is some kind of definition, right? Ubiquitous, right? This is ubiquitous mean whole idea, wide range of idea, right? Ubiquitous, convenient, and it is some kind of convenient, right? It is have more spaces, right? And on-demand network access, and kind of on-demand network accessing and servicing model to share pool of configurable computing resources. To share pool of configurable computing resources, right? You can configure these resources, right, over the on-demand network access, right? Like network, right? You can have networking cloud computing and servers, and also storage, right? And storage, and then storage applications, and also services. You have some kind of services, right? We will discuss those things, right? You know this one, right? Networks, servers, storage, application, services like Facebook, right? Some kind of thing, right? Google Workspace, some kind of things, right? This kind of services that can be rapidly provisioned and released with minimal management effort of service provider interaction. That can be rapidly provisioned and released with minimal management effort or service provider interaction. Minimal management, that means if you are using this cloud computing, the user or the consumer need to have minimal management effort, right? Then he can easily manage this infrastructure. That is some kind of advantages of this cloud computing or service provider interaction, right? So this is some kind of graphical representation. Cloud computing, this is cloud, right? Cloud, right? I don't know how this word came, right? However, this is some kind of the idea is like cloud, right? Cloud is in air, right? Anyone can access the cloud. I think that is the originating of this term, right? Cloud computing, right? It has databases, it has apps, right? It has some kind of coding like GitLab, right? Coding infrastructures, coding what we call coding platforms, right? Then mobile phones you are connecting to the cloud using, then PCs are connecting. Then now also this kitchen appliance like your CCTV camera, right? Or maybe your kitchen sink, right? Maybe your some kind of devices in your kitchen, maybe your microwave oven also connecting to internet, right? This kind of things are available, right? So now the cloud is that kind of wide area. Right, that is some kind of introduction to the cloud, right? Essentials, right? Characteristics. Now, time is now 6:44. Can anyone remember what is the time we started? Nearly 6:50, neither. 4:50, neither. 4:50 වගේ පටන් ගත්තේ නේද? So I think it is nearly to 2 hours, right, Ari? The time I want to finish this one is I think 6:30 because okay, however I take some 15 additional minutes because it is getting late to start, right? I will stop at this point, right? And according to your request I will share this document with you, this PDF or whatever the document. I will share with you, then you can study, and if you have any question you can ask, otherwise we will terminate at this point, right? Because I am still at the office, right? Still I am at the office, then I want to go home, right? You can see me, I am still at the office. because normally I am not going to home because not I am not at the home. Actually, I am at my boarding place. Normally there is power cut, right? So if I went sometime to my place, then I cannot conduct the lecture because in here in my university there's generators there. So that's why I'm staying here and conducting this lecture series for you from here, right? Okay. If you have any question, you can ask. Otherwise, we can stop.